Hey everybody, it's Derek here. Welcome to week 2 of the SysOps Admin Associate Study Guide. This week, as you can see, we are going to be looking at compute. And if you've taken the Solutions Architect course that we have, this will look a little familiar. However, some people haven't taken that path, and for all the associate level certifications and beyond, it's very important to be familiar with the very foundational domains of compute, database storage, and networking, because pretty much any solution or application running in cloud is going to use some combination of those. All right. So, having said that, let's go ahead and get right into it here. So, compute is the tier of service that's used to process workloads, that's used to handle application logic, evaluate rules, react to conditions, pretty much anything, right, that needs doing is in some way, shape, or form compute. And you could think of it as like the brains and the processing power, right? It's the backbone for everything that kind of powers everything else, all right? It's tied closely to CPUs and RAMs. And even if you were to open up the task manager on your computer and you go to your performance tab, you'll see the first two that pop up are in fact CPU and the memory, right, the RAM. So very important aspects of your compute workloads that you're going to be asked about multiple times. But when we think about compute, we've got two main services, okay? We've got EC2, which is for longer term use cases, so workloads that you're going to be doing over a extended period of time. You're going to want to be thinking of EC2. But there's also Lambda, which is a nice serverless, very handy compute service that allows you to utilize short-term power to do functions and tasks. And to give you an idea, it has a runtime limit of 15 minutes. So again, it's best suited for short-term use cases like maybe processing or calculations, things of that nature. Okay. So those are going to be the main two services you are going to want to keep in mind. Some other applicable services, though, that are in this compute domain that we'll just briefly touch on so that you're familiar with them, but we don't necessarily need to go into the weeds with them, are ECS, ECR, EKS, which all really kind of relate to containers, Elastic Beanstalk, Batch, ELB, and Outposts. Okay. We're probably going to spend 80% of the time here today on EC2 and associated features of that, like auto scaling and load balancing. So prepare for that. All right. So here we go. EC2. It is the flagship AWS compute service that allows you to launch virtual machines, but on AWS and in EC2 they call them instances. If you are familiar with like Azure, for example, they call them VMs, but it's basically the same thing, right? It's computing resources. And a VM is an emulation of a physical computer using software, right? So it's like opening up a laptop and doing everything you would expect to be able to do on a laptop, but obviously you don't have the actual physical laptop, all right? That's what an emulation is. And you can have multiple VMs that run on the same physical server, allowing you to share costs of that server with other customers. Okay, that's really where AWS kind of makes their money, is emulating all these VMs on all their servers around the world, and you just kind of pay to use it as you need it. All right. So from this point on, just to avoid any confusion, we're going to refer to these as instances because that's what AWS refers to them as within EC2, so that's what we're going to call them. All right. EC2 instances are very flexible. You can configure them to meet any kind of business requirements. Maybe you need some that are larger or smaller, more or less resources, more or less quantity. It's, again, very flexible, okay? And you can break down EC2 into the following components. All right, you've got Amazon Machine Images, otherwise known as AMIs, instance types, instance purchasing options, tenancy, user data, storage options, and security. Okay, and we'll go through each of those domains here shortly. All right. So AMIs, Amazon Machine Images, are templates of pre-configured instances that let you quickly launch a customized instance. So think of AMIs like everything that, makes up an instance except for the properties of the actual physical hardware of the instance, okay? So it consists of like an operating system, an OS, application configurations, and any other custom configuration you want, and a block device mapping that specifies which EBS volumes you want to attach, if applicable. And you can also purchase AMIs from the AWS Marketplace if you have like a specific use case for an AMI and you don't necessarily feel like building one out from scratch, you can do that. So to give you, a little visual here of what an AMI kind of looks like and how it works, let's say over here you have this AMI, and I purchased this AMI from the AWS Marketplace. All right, I can take this AMI, this template that consists of, again, like an operating system and some other configurations, and I could map it over this T2 instance. Okay, we'll talk about different instance sizes here shortly. I could also take this AMI and map it over a different EC2 instance in the A1 family, and same thing for the C5 family. Okay, so again, you have this AMI, this image that specifies essentially a blueprint for what you want to reside on your EC2 instance. Okay, but you still have to specify, the actual hardware. So again, like CPU, RAM, other hardware properties like that when you spin up this instance with an AMI. Okay, so that is AMIs. And if we move on here, we'll now get into instance types a little bit. So you've got 5 types of instance families that you can use. And again, this will all depend on the use case that is going to be required for said instances. Okay, you've got general purpose, which is just a balance of compute memory and networking resources, generally used for dev test workloads. After a while, you'll know what your production, your important and critical workloads are, and you can get a more appropriate instance. But for the most part, general purpose can meet most requirements, but long term, you're probably going to want to get something a little more specific. So some of those options are compute optimized instances, which are ideal when you have high processing power requirements. So maybe you have like some scientific modeling methods or some batch processing you're doing. Those are a couple common use cases. You've got memory optimized instances that are used for workloads, processing large data sets in memory. So acting as an in-memory database, for example, or some other real-time big data analytics. Okay? You've got accelerated optimized, which is primarily used for machine learning. It's a slightly newer instance family type. But again, it's mostly used, like I said, for machine learning or even like GPU intensive applications. So the GPU, your graphics processing unit, so very graphical applications. Maybe you have like image rendering applications, I don't know. And then finally, you have storage optimized instances that give you high read and write access to large data sets that are on your local storage. Okay? This could be perhaps used for data warehousing or online transactional processing, OLTP. But again, most of the time you can just get away with the general purpose, but long term, you're going to want to get something more specific that's going to bring more value to your business. Okay? So as you can see here, you have options to select your instance type when you are booting one up. As you can see, there's quite a few, 366 in this case, and Of course, they're always adding and removing more, making things better and more efficient. So if you want to see, for example, what some of these instance types are with the abbreviations and everything. So this is kind of the T family and this kind of general purpose, very low free tier eligible family here that I have selected. You can just launch an instance, and then one of the prompts will say instance types, just like you're seeing here, and you can go through and look at those. You could also, by the way, if you aren't sure about anything, you can just, Google, for example, EC2 instance types, and pull up the AWS documentation. Okay, make sure you pull up the AWS documentation. That's very important because it's obviously going to be the most accurate. Pull up their documentation and you can see much more in-depth explanations of anything you would need to know, okay? All right, so EC2 pricing models. This is basically how you're going to be paying for your instances, okay? They, for the most part, aren't free. There is a free tier, obviously, but, for businesses and actual use cases, you're going to be paying for it. So it's important to know what your options are so you can be strategic and save money when possible, okay? So the first one, and probably the most common, is on demand, which is going to be the defaults. And as the name would imply, it's kind of just on demand, pay as you go, which just means you only pay for what you're actually using. The price is going to work based on hourly rates. Okay, so it's like, 50 cents per hour, $12 per hour, whatever it is. You'll see that when you're actually going to set it up. It'll list the price there. Reserved instances. This is going to be best for applications that have a steady, predictable usage. So again, maybe a business that's running a critical workload and it makes you money, so you're not going to stop running your applications. So when you use reserved instances, you can commit to 1 or 3 years of usage with a longer term, giving you more savings. So if you commit to 3 years instead of 1, you'll get more savings. These reserved instances can be standard or convertible. Both are going to offer substantial savings when compared to just the on-demand instances, and you can modify the standard reserved instances or exchange the convertible reserved instances, right? So, for example, if you have a standard reserved instance, you can modify some of the attributes of that same instance, but if you have convertible instances, you can just outright exchange that instance for another instance with different attributes, okay? You can pay either upfront, partial upfront, or no upfront. And of course, more money upfront is going to be more savings. You'll get the highest discount if you pay all upfront, and you won't have a monthly payment. But if you pay, partial or no upfront, you'll have a monthly payment, with of course more upfront being a lower monthly payment. Okay? These reserved instances can be shared between accounts if, for example, you have multiple accounts in an organization. And if they aren't being used, you can sell your standard reserved instances on the AWS Marketplace, which is pretty neat. So as you can see, there's quite a few ways to save money just in this reserved instance tier alone. All right. Spot instances are going to provide you with the greatest savings by far for your instances, but there is a caveat. Okay? It's designed for workloads that have flexible start and end times, because AWS can take back this spot computing capacity at any time. And essentially, spot instances are just unused compute capacity from AWS that you can bid for. All right, and there's 3 scenarios where your spot instances can be terminated and reclaimed by AWS. Okay. Scenario number 1 is when it's just requested. So you as a customer say, all right, I'm done with this. I don't need it anymore. They'll take it back. Scenario 2 is when the spot price of spot instances is greater than your current bid price. Okay, that just means that the spot price is higher because there's maybe more demand, so other people are going to pay for a higher spot price, so they're going to take it back from you. Or if they're just outright lacking unused capacity for whatever reason, then they're going to reclaim that instance because they need it for someone who maybe is spinning up, on demand or needs reserved instances. Okay. And you will get I believe it's a 5-minute warning. It's a few, let's just say a few minutes of warning time before they reclaim your instance. It's not like it's instant. So they do give you a warning, which is nice of them to do. All right, so we're going to finish up pricing models here, then we'll take our first break. So you also have scheduled instances, which allow you to pay for instances that will run on a daily, weekly, or monthly schedule. So for example, maybe you have, 5 hours per week that you need these running instances, okay? Because you have some kind of maybe end of week processing that you want to do and just cram it all into, the last 5 hours of Friday. I don't know. It's similar to reserved, but you're going to pay for these whether you use them or not over a 1-year term, okay? If you remember, you can sell some of your reserved instances back, the standard reserved instances, to the marketplace if you're not using them, okay? You can still do all partial or no upfront payments, but it's important to note that as of this point in time, which is July 2023, AWS currently doesn't have reserved capacity for scheduled instances and is instead recommending using on-demand capacity reservations instead. All right, but it's still a thing that exists that you may get asked about on your test, so it's good to know that it's an option. But practically speaking, on-demand capacity reservations are going to allow you to reserve instances in a specific availability zone for any duration, right? Not just a year, for a specific instance type. All right, so it's pretty granular in the type of instance you are requesting. There's no time commitment required, and you can create and cancel these as needed, so obviously more flexibility. But, that kind of comes with the fact that there's no billing discounts, right? You trade billing discounts for flexibility. You're still going to have on-demand instance limits per region that apply. So, for example, you're going to have, I think, a limit of maybe 20 instances per region, if I remember right. And you can't go above that, but you'll have to double check me on that. So that is on-demand capacity reservations, all right? So let's go ahead and take our first break for a few minutes here, and when we come back, we'll pick up with EC2 tenancy types, okay? So we will be right back here in a few minutes. back into it here. So we have EC2 tenancy types to get to next. And EC2 tenancy is essentially how your provision instance is living on AWS's physical server. And like I mentioned earlier, it's what allows for the substantial cost savings between customers, because you've got hundreds of thousands, if not millions, of customers over time using the same AWS hardware as they start, stop, allocate, deallocate instances. And we're all just kind of pitching in to pay for those servers that AWS, purchased and is maintaining. All right, but there's three types of tenancy. There is the shared tenancy, which is the default, where multiple AWS accounts are all using the same physical hardware. You've got a dedicated instance, which is where your instance runs on single tenant hardware. So it's not an entire box, right? But it's a section of a server that is, only for you, that no other AWS accounts are on. Whereas a dedicated host is an entire physical server that you can control and configure to your heart's desire. A lot of times, maybe some enterprise level corporations need this for licensing requirements or security and configuration requirements. Maybe you are a company that has government entities for customers, and they require you to have a host designated for only their data. That could be an option, but for the most part, you're just going to be using shared tenancy. Okay. So EC2 user data is what allows you to enter commands that will run when an instance first boots up. So for example, when you launch your instance, you can have it right off the bat automatically install a web server, for example. As you can see down here, we're installing Apache, okay? Or it can download the latest OS updates for whatever maybe Linux distribution you're using, for example. But we're not going to get too much into this because that is more of the developer niche. But it's important to know that user data allows you to run and install things when an instance first boots up, okay? EC2 storage options. So you've really got two main types here. You've got persistent and ephemeral storage, okay? Persistent storage is likely going to be the go-to, and it uses EBS volume, so elastic block storage. The reason it's persistent is because EBS volumes can be separated from an instance and they can be reattached to another instance, or if an instance fails, whatever's stored on your EBS volume will remain regardless of the status of the instance it was attached to. But they're logically attached to instance via the AWS network, so they take care of all that for you, which is nice. You can, like I said, detach a volume from an instance, retain that data, and put that volume onto another instance, or reattach it to the same one later if you want. And then you can encrypt your volumes, and you can also take backup snapshots. All right, so very secure, very durable. Ephemeral storage, on the other hand, is local storage physically attached to the underlying host that your instance is on. Okay. And it's designed to be temporary, not recommended for critical data storage, because if the instance is stopped, terminated, or if there's some kind of disk drive failure, your data's gone, all of it. Okay? You can reboot your instance without losing data, but if you're storing critical data as ephemeral storage rather, then you're kind of playing with fire. So keep that in mind when you are considering which type of storage you want to use with EC2, okay? All right, EC2 security essentially can be broken down into three areas, okay? We, as a best practice for AWS, want to have security at multiple layers. This is a few ways we can do that. So you've got security group configurations, you've got key pairs consisting of public and private keys, and you've got regular OS patching. All right. So if we look at this top picture here, this is going to give us a visual of what security groups are. So say, we've got, we can just look at this top picture here. We've got a security group around these instances because security groups are going to act at the instance level, whereas NACLs are going to act at the network, right, the subnet level. We'll get more into that later in the security section, but just know that for the purposes of where we're at right now, security groups act at the instance level, and they control, traffic. Basically, it's allowed to reach your instances. Okay? And we also have key pairs, which dictate how you can access your instance. So say you want to RDP in, you essentially would generate a private and a public key. Okay, the private key you download, and you then when you go to create your instance, it creates an AWS key pair with the public key that was generated. Okay? And then you map your key pair with your EC2 instance. Okay, so it kind of decrypts and encrypts the login process. All right, and just as a rule of thumb, again, when we get to like encryption, we'll talk more about this, but public keys generally encrypt and private keys usually decrypt. All right, so it's called enveloped encryption, so remember that, but again, we'll really drill down into that in another week when we talk about security and encryption. Okay, and of course, regular OS patching. If there is a particular version of an OS you're on and it gets discovered that there's some kind of security breach, or vulnerability rather, then if you're not patching your OS to remediate that, then that's on you, and that's obviously not very secure. So you want to have regular OS patching, perhaps set like a maintenance window where you automate it, something like that. Again, we'll get more into that later on as well. All right. So auto scaling groups and load balancers. So very important concept here, very powerful concept, because this is what allows you to automate pretty much everything and respond to increasing and decreasing demands, again, automatically, right? When we think about operational efficiency, automation goes pretty much hand in hand with that. So we want to achieve the highest level of automation we possibly can, all right? So auto-scaling groups and load balancers, so your elastic load balancers, work hand in hand, and they are what allow you to achieve high elasticity and scalability for your compute workloads. Okay, two very important concepts and selling points of cloud computing. All right. So auto-scaling groups can automatically add or remove instances to meet your performance requirements. And it's based on metrics and thresholds, such as, for example, CPU utilization, right? If it's increased above 80%, for example, you can say, all right, because it's that high, I want to add another instance to make sure that my end users are getting the best possible performance and lowest latency. All right. Load balancers are going to be what distributes traffic between your instances to achieve the best possible latency. All right. There's three primary types of load balancers. All right. There's an application load balancer, which is used for distributing traffic from the web to targets in your network. We'll talk more about what targets are in a little bit. We'll actually elaborate more on ELB in general here shortly, but targets could be like EC2 instances, containers, or a few other things. And application load balancers are going to work with HTTP and HTTPS traffic. So at layer 7 of the OSI model, right? Network load balancers work at the network level, so the level 4 of the OSI model. And it's used to handle millions of requests per second using TCP and UDP traffic. So if you ever get a question talking about very high performance with, the ability to handle millions of requests per second, start thinking of a network load balancer. Right? And then a gateway load balancer is used to distribute traffic across third-party virtual appliances It's not as commonly used. You definitely want to be more familiar with app and network load balancers, okay? And one other thing to note here is that there is a classic load balancer that was primarily designed to support the EC2 Classic network, but the Classic network was actually retired about a year ago in 2022, August 2022. So it's not really recommended to use classic load balancers anymore. In fact, they actually have a migration wizard to help you convert those into either app or network load balancers. Okay, so keep that in mind. Just know it's there, it's a thing, but it's probably not really ever going to be used. All right. So EC2 auto scaling is essentially what allows you to use customizable and defined metrics that allow you to increase, otherwise known as scaling out, or decreasing, scaling in, the size of your EC2 fleet automatically with ease. Okay? Some of the main benefits of EC2 auto scaling include automation, as the name implies, which eliminates the need for your operations team or you as a SysOps admin to manually add and remove resources. Right? Obviously, this would be very tedious. You'd have to sit there and monitor all your dashboards and everything to see what's doing what, and then manually add things. And what if it happens at like 2, 3 in the morning? Are you really going to want to wake up and spin up new instances? I don't think so. All right. It gives you a higher level of customer satisfaction because it ensures that your capacity needs are always met. So if that's the case, it's unlikely your customers are going to have performance issues because you've got enough instances to meet the demands of the workloads. All right. And of course, cost reduction because you can automatically remove these instances and resources when it's not needed. So you don't keep paying for things that you're not using, okay? So to kind of visualize this, we have a auto scaling group down here. And when you set this up, you are going to need to specify a minimum, desired, and maximum size, okay? So a desired capacity is basically going to be the benchmark for where auto scaling tries to keep the amount of instances you have. So in this case, we're saying, okay, we would like to have 2 instances in our fleet here. That's kind of the ideal scenario for most of our traffic, most of our workloads. But no matter what, we need to have at least 1 instance. All right. So at the very least, we want 1 instance. All right. That's our minimum. But there are times where maybe a holiday comes and we sell, apparel. And everyone's going Black Friday shopping. In that case, we're probably going to get higher demand, so we need to scale out an additional 2 instances. Okay, that's going to be the maximum size that will meet our performance requirements. All right, but once that holiday ends, and our traffic and our demand dies down, we don't want to keep those instances because we'll just be paying for them even though we're not really using them. So we can reduce those instances back down to our desired capacity of 2 to keep things running smoothly while, again, not paying for additional resources, okay? So that's the beauty of auto scaling. You can meet continually changing demand and also save the most amount of money, all right? Pretty much all automatically, all right? All right, so EC2 auto scaling components. You've got a few different components here. You've got essentially launch configurations and templates. Templates are a little more modern and user-friendly. So you're probably going to see more with them. But some things that you are going to see on a template are going to be the AMI. So again, how do you want your instances to look once they're started up? Again, you are going to want to specify the instance type because AMIs don't specify, the underlying hardware of your instance, so you need to specify the instance type. Do you want to use spot instances? You can say, yes or no to this on your template. Do you want to use a public IP address, or do you just want to have a internal private IP address because this isn't going to be a public-facing instance? Do you want to have some kind of user data that's, installs some kind of application or something else when your instance boots up? Do you have a specific storage volume or security group configuration that you need applied to this instance when it gets started up? All right, all these things can be specified on your template to allow you to very flexibly and automatically say exactly how you want your instance to be formatted and how you want it to look when it gets built up automatically, okay? And then auto-scaling groups, like we just talked about, tell AWS the minimum desired and max amount of instances you want. And you can also say where to scale them, so if you want them in a specific availability zone, for example, okay? Auto-scaling policies. So this is basically going to dictate how your auto-scaling actually scales, okay? And there's 4 types of policies you can use. You can use a manual auto-scaling policy where you do it manually. Again, you really want to try to avoid manual operations as often as you can. But for this particular use case, it's really only useful if a big spike is coming that's not regular. So maybe your company has like a annual event that you put on, and your website's going to get a ton of new traffic. You could manually add more instances to get ready for that. You can also use dynamic auto-scaling policies, which is the primary way to use this, which uses either step scaling or target tracking. Okay, so step scaling is going to be how you add or remove a specified number of instances based on a tracked metric, so CPU usage, for example, and it gets tracked via CloudWatch. And because this is the SysOps Admin Associate exam, we're going to go into quite a bit of detail with CloudWatch at another time, okay? But you've also got target tracking, which is similar to step scaling, except you just define a threshold, and AWS will automatically add or remove instances to meet your demand based upon whatever specific threshold you define, okay? You've also got scheduled auto-scaling policies, which add or remove instances based on time parameters. So you can have auto-scaling, again, add or remove instances, maybe at a specified time or day of the week. And then you can also have predictive policies, which use ML kind of behind the scenes that predict when your traffic is going to go up or down. And based upon those findings, it will add or remove resources for you, okay? All right, so let's go ahead and take our second break real quick. And then when we come back, we are going to get into elastic load balancers. All right, so we will be back here in a few. if we can finish it up in this last work stretch. Okay. So elastic load balancers. When you combine this with autoscaling, you're going to create very robust, reliable, and fault-tolerant architectures. So the main function of an elastic load balancer is to manage and control the flow of inbound requests that are destined to a group of targets, as you can see here. Right? And again, these targets could be EC2 instances, Lambda functions, containers, or even just a range of different IP addresses. All right. So elastic load balancers have three main components and a couple other subcomponents we'll look at here in a second. But the main ones that you really want to be familiar with are listeners, target groups, and rules. Right? So a listener is what's going to define how the inbound connections to your load balancer and subsequently to your resources are routed to each target group that are based on ports and protocols set as conditions. So for example, maybe you have a load balancer here and it's got two listeners. Maybe one listener is for HTTP traffic and the second listener is for HTTPS traffic. Okay? A target group is just a group of resources that your elastic load balancer eventually routes traffic to. And you can have multiple target groups in an ELB, each with their own listener configuration. Okay? And rules are going to be associated to each listener you have configured. And you can think of rules as if-then statements that utilize conditions and actions. So for example, in this one up here, it's going to say, okay, if this is HTTPS or HTTP traffic, then, send it over to this instance, for example. So you can have elastic load balancers with one or more listeners. Okay, and you can see we have two listeners here. Each listener can have one or more rules. Okay, so this listener has one rule, this listener has two rules. Each rule can have one or more condition. Okay. But all conditions in a rule point to a single action. Okay, so you can't have a condition pointing to multiple actions. All right, because you just want each request to end up in one place. All right, so that's kind of the main components of an elastic load balancer. But you also have kind of some supporting ancillary components. One of the most important ones are health checks. And health checks are going to be essentially when ELB is going to contact your target resources with the specified protocol to ensure an expected response. So for example, you would want to contact maybe a target EC2 instance with HTTP protocol to ensure that it responds with like a 200 status code, which means okay, for example. But if no response is received, then ELB is going to mark the target as unhealthy, and it's going to stop sending traffic to that instance, okay, which is pretty neat. All right. Internal and external basically means that external load balancers are going to be internet facing, so they're going to have nodes with a public DNS name that can be resolved to a public IP address and potentially an internal IP address if that's where the traffic's going to end up later. Okay? If you have an internal load balancer, though, it's obviously got no public IP address. It's only got an internal IP address, and it's only going to serve requests that originate from within your VPC. Okay? And ELB nodes, so each load balance or each availability zone rather that you want to use your elastic load balancer with needs a node in it, and this is going to be automatically created once you just kind of specify the AZs that you want to operate in. And to do cross-zone load balancing, again, each availability zone just needs a node. So your elastic load balancer basically just needs to exist in whatever availability zone that you want to operate it in. Okay. So ELB does indeed support SSL, which you would expect, considering you should be using SSL for web apps anyways. But this is going to be using the application load balancer. And that provides a robust feature set for your web apps that are running HTTP and HTTPS protocols. Right? You need to first specify HTTPS and port 443 as listeners, like we looked at earlier. You then need to apply your server certificate and an associated security policy to your load balancer. Okay? This is commonly done with AWS Certificate Manager. You can do it with your own certificates, or you can use Certificate Manager to create one and then apply it to your load balancer. Right? You want to note too that not all regions support Certificate Manager. Most do, but not all do. And if that's the case, then you can use IAM to manage your certificates. That's a whole nother rabbit hole, so we won't go down that one. But again, if you want more information on that, just check out the AWS documentation. Okay? So an application load balancer, it's used to support HTTP and HTTPS traffic at the application layer, so layer 7 of OSI model. It can also support SMTP and NFS protocols. Cross-zone load balancing is always enabled, right? So it gives you that level of availability, all right? And again, you can see here that it can route to maybe a Lambda function, some kind of container, or an instance, okay? Network load balancers, again, TCP, UDP traffic, layer 4. This is kind of the key words here. It's designed to handle millions of requests per second with very low latency, okay? And finally, gateway load balancers are used to balance inbound and outbound traffic between virtual appliances, just basically instances that are running third-party network appliance software, all right, and your associated VPC, okay? All right, so now we'll just kind of go through briefly these sort of sub-services that are part of compute, but you're not going to be really drilled on them during the test like you will be with like load balancing and EC2. So ECS, Elastic Container Service, supports Docker-enabled applications, packages containers across a cluster of instances. Containers essentially hold everything an app needs to run except for an operating system, which is what gives them that element of being decoupled and makes them very lightweight. All right? It's done primarily by using AWS Fargate behind the scenes to manage and provision instances and clusters for your containers. Containers can be monitored with CloudWatch to see events like scaling in or out. And ECS clusters are basically a collection of EC2 instances that act similar to an EC2 instances, right? It's just a collection of instances working towards a common goal. And they're going to aggregate resources like their CPU and memory, but you can only scale them in a single region, okay? Elastic Container Registry, ECR, provides a secure location to store and manage Docker images. And it's got a couple different components, including the registry itself, which lets you host and store Docker images, and an authorization token, which grants your Docker client access to this registry, a repository, which holds, or it's basically objects within the registry where you can group images into different categories, repo policy, which controls actions and access to your repo. Okay, and then you have images, which are just the actual objects that you build out your containers with. Right? Elastic Kubernetes Service is just kind of used to support Kubernetes, which is a container orchestration tool designed to automate, deploy, scale, and operate your containerized applications. It integrates with Kubernetes to abstract the control plane and leave you only with managing the worker nodes. Again, don't have to go into too much detail here, but just know that the control plane is essentially what controls things, right? It schedules containers onto nodes and tracks the state of all your Kubernetes objects. And your worker nodes are what actually make up the Kubernetes clusters. So basically just EC2 instances, and they use a specific AMI like you would expect an instance to use anyways, okay? All right, Elastic Beanstalk is the AWS managed service that takes your code and provisions the required resources in AWS to make your web application operational. And it does this by utilizing EC2, autoscaling, and load balancing behind the scenes. The service itself is free. However, the resources that actually get provisioned, like instances, for example, are not free. So the core components of Beanstalk include the application version, which reference a section of deployable code, because you're probably going to have different versions of your application. The environment, so the application version that has been deployed, so you can have maybe a test environment, a production environment, things of that nature. Environment configuration, which is just parameters and settings that determine resources deployed to an environment and how they behave once deployed. An environment tier is going to be a web server or a worker tier, and this is going to be based on if the application handles HTTP requests or not. Configuration template is going to be your baseline for making a new environment, and the application itself is going to be kind of the end product. It's the collection of different elements like environments, environment configurations, versions, everything that's, again, kind of the end product. Okay. AWS Batch is used to manage and run batch computing workloads within AWS. Batch computing generally requires large amounts of compute power across a cluster of resources to complete a series of tasks. And the components of batch are jobs, which is the core component. It's the actual unit of work that's run by batch. Job definitions specify how a job runs and with what type of configuration, so how many vCPUs, what kind of mount points, etc. Job queues, kind of self-explanatory, where jobs sit until they run. Job scheduler handles the running of jobs and which environment they actually run from. And then your compute environment is just going to be the environment that has specified resources that you need to carry out and actually do your jobs. It's generally ECS clusters, and it can be managed or unmanaged. Okay. AWS Outpost is a relatively new service, but it's used to support a hybrid environment, which again, that's just a combination of cloud and on-premise resources. And it's basically a piece of physical hardware that AWS delivers and sets up for you in your data center that allows you to use native AWS services. And of course, this could communicate with the cloud as well. But you've got two options for Outposts. You've got VMware on AWS, which runs your native VM infrastructure, if you're doing something like that. And then you've got the native AWS variant, which is just going to let you use same API or the existing API management tools that you would use and come to expect in AWS. Okay. You order racks to the console, and then it's kind of nice because AWS will actually patch their racks when it's needed. All right. AWS Lambda is that primary serverless sort of short-term compute workload service. All right. Again, serverless just means that you don't have like a dedicated server running jobs. You just submit a job or in the form of functions is what they're called in Lambda, and then just some server somewhere runs it. Okay. And like I just said, it's comprised of functions, which is similar to how EC2 uses instances. You need to write your function, and if you've got any sort of experience programming, you kind of know what a function is, but it's basically a piece of code that does something. And Lambda supports pretty much all modern programming languages. Okay, and after you write your function, you either invoke it manually or automatically based off of events. Automatic is going to be ideal in most cases. You only pay for when your functions are running, so how long they run for and how much compute power they actually use. And then you can monitor functions and code that are being run using CloudWatch. Okay? All right, so we've got, I think it would be about 5-10 minutes before we were set to take our next break. So let's just go ahead and get through this compute summary real quick, all right? If you want to take a break before we do this, feel free to pause me and come back, all right? So, Amazon Machine Images. AMIs are templates based on existing instances that you can use to quickly launch new instances. Remember, they contain pretty much everything you need to template an instance except for the underlying hardware specifications. Instance types, you can have different types, basically defined by their values and properties, like the amount of memory storage, network performance, etc. It's important to note that most instances do support ephemeral storage, but some don't, and it'll kind of say when you're going to provision it if it does or doesn't. More specifically, it'll say if it doesn't. Otherwise, it's just kind of assumed that it does. So you've got general purpose instances, which are used for just various broad use cases. Compute optimized, used for compute heavy workloads like batch processing or scientific workloads. Memory optimized, used for processing data sets in memory, such as big data analytics. Accelerated computing, used for very high performance compute workloads like machine learning or GPU intensive applications. And then storage optimized is used for workloads that need high IOPS performance, okay, like data warehousing. All right. EC2 purchase options. So you can have on-demand instances which can be launched or terminated at any time with pay-as-you-go pricing, generally used for irregular, interruptible workloads, maybe like test environments. Spot instances are going to be by far the largest cost savings, but you should plan on having your workloads interrupted if you're going to use spot instances. Right? Reserved instances can be purchased for 1 or 3 year commitment terms, and you can pay using all or partial or no upfront. Of course, more upfront is going to be a lower monthly payment. Scheduled instances are when you pay to reserve instances on a recurring basis. Again, it's best for workloads that maybe aren't super frequent, but they are going to run on a predictable schedule. Right? Capacity reservations are where you reserve capacity for EC2 instances with specific attribute types or specific attributes, right, such as instance type, like the platform, the availability zone, etc. Okay. EC2 tenancy, you can have shared, which is the default, where you share the underlying hardware with other EC2 customers out there in the world. Dedicated instances, which allow you to run instances on single tenant hardware. Dedicated hosts, which give you an actual entire physical server, not just a segment of a server like a dedicated instance. And you can configure a dedicated host, the entire server, pretty much however you'd like. Okay. EC2 security, so key pairs encrypt credentials to the instance, and again, the public key encrypts, private key decrypts. You can use the same key pair on multiple instances, which is kind of nice, very convenient. EC2, and then again, EC2 security, you can also have security groups, which control access at the instance level. EC2 auto-scaling, so you can automatically increase or decrease your instances to meet the demands of your application. Scaling up means increasing the size of an existing instance, and scaling out means adding more separate instances. So sometimes you'll see scaling up and scaling down, scaling in or out used interchangeably. AWS likes in and out more than up and down, so just remember that, but it's basically the same thing. And then launch templates define the AMI, instance type, and other properties of a new instance when it's launched, very commonly used with auto-scaling, of course. And then auto-scaling groups let you define a minimum, desired, and max capacity of instances. Okay? EC2 storage, you've got 2 types, ephemeral and EBS, which is that persistent storage. So ephemeral resides on the same physical host as your instance, and if your instance fails or is stopped or terminated, you're going to lose that data, all of it. Okay, but EBS volumes provide you with persistent storage that will still be there, still remain if an instance fails, and of course you can move an EBS between different volumes. Okay, or between different instances. Sorry. And elastic load balancing controls and routes the flow of incoming traffic. It uses listeners, target groups, and rules, but it also has health checks as well. And it can be an application, network, or gateway load balancer, or a classic. Remember, there is a classic. You're probably not ever going to use it. Right? And then targets can be EC2, instance fleets, Lambda functions, or containers, or a range of IP addresses. Lambda is the main service that's used to run serverless compute workloads. It uses functions, and you only pay for the compute power used when your functions are run and how long it runs for. Okay, but generally, if it's running for longer, it's going to be using more compute power. Right? Functions that are triggered by supported event sources, sorry, it's kind of confusing. So Lambda uses functions that get triggered by supported event sources such as S3. So that's kind of that automated running of functions we referenced earlier. Okay. And that is going to bring us to the end of compute. Nice job. We made it to the end. Just over an hour, but that's totally fine. So compute's definitely a big section, guys, but remember that EC2 is kind of the main core component of compute. So get quite familiar with it. Of course, do the labs, read documentation. If something doesn't make sense, maybe I didn't explain it well, and it just doesn't make sense, go look up the documentation, right? Looking at documentation will only get you more familiar, more experienced, more prepared to take and pass this exam, all right? So that's going to do it for this week, week 2, and we will see you next time for AWS storage.